Welcome back to College Algebra videos. We'll talk today about exponential and logarithmic functions. And in fact, today our goal is to be able to write, this is sort of an easy goal, is to be able to write exponential equations in logarithmic form and to write logarithmic equations in exponential form. Now it turns out that this is a sort of a basic skill. If we learn this skill really well, then this will allow us to really solve different types of equations. So let's make sure to learn this really well, because then this will be very useful, especially on your test, especially multiple choice test. Okay, here we go. First of all, there is a relationship I want to start off with. We've been talking about this a lot, and so one of the things that hopefully you remember by now is that I told you a while back that if you have the function that is an exponential, that it's related to its inverse, which looks like this. And so remember that the exponential function is just the inverse of the log function and vice versa. But another way, and what I want you to remember, is the following, that we talked about inverse functions and how it means just switch the x and the y. And so here on the left, you want to think of this x as the input and as this y as the output. And so when you find the inverse, we switch these, remember? And so now notice that the y has become the input and that the x has become the output. And so this is a nice relationship to kind of get used to, the fact that you can go back and forth. And this is what I had mentioned in class also, how it's very nice to go back and forth between worlds. Sometimes you have an exponential function that's very difficult to solve, so you make a logarithmic, which is much easier. Or vice versa. Sometimes you have a logarithm that's very difficult to solve, but you make it an exponential, and that makes it easier to solve. And so that's why I have these, the symbol here in the middle is a double arrow, means that we can go back and forth between these two worlds. Now, one way that I use to remember this is as follows. I say, I usually have a base, and I raise it to some power, and it gives me some answer. So this is what I have here on the left. A is the base, so this is the base, A. X is the power, and in this case, Y is the answer. So what I like to do is go back and forth between these worlds, and so I notice that here, the base is what goes here at the bottom. The answer is what goes in parentheses, or what goes inside of the log. You don't have to use parentheses, but I usually do. And the x stands for the power. And so this is what I use to help me remember. Sorry, I couldn't fit that in. But this is what I use to help me remember how to go back and forth. I know that it's log, that there's the base, here's the base. This is really the power, and the answer. The y is the answer, and the x is the power that I'm looking for. And so I use this to go back and forth. So I'd suggest that you maybe write something like this down somewhere and try to memorize this, or write the original one. Write the one I have up here. Okay, so let's go ahead and start using this, and hopefully you'll remember how to go back and forth. I'll try to say it in words, but I do want you to go back and forth. So if you write this, it's good so that you can see what I'm doing. Okay, so here we go. We want to write each of these equations in logarithmic form. So we're not going to solve anything. We just want to see if we can translate. And so remember, here, this is the base. The 4 is the power. And the 81 is the answer. So when I try to translate, so in logarithmic form, so I'm going to abbreviate log form. What I would do is I would say, okay, well, this is really log. The base is 3. The answer is 81, so it goes here, and so this is 4. And so now you have an identity or something you can remember. This is the answer, by the way, but what I want you to get out of this is if ever you plug in 81 into log 3, if the input's 81, then the output's 4. Notice that's sort of the opposite of here. Up here, if the input is 4, the output's 81. So now we're saying if the input's 81, the output's 84. Okay. So you might want to try the next one on your own, maybe pause the video. But here's what it would look like if you haven't paused, or if you're coming back from a pause. The way this one works, we say, okay, so log form. Here, we can say that the log base 1/2 of 8 is equal to negative 3. So this is a correct form. Now, there are other ways to do this. And again, it depends on how you view the world. So this is all depends on your perspective. Another way to look at this equation is to say, oh, the negative, doesn't that just mean to flip? Doesn't that just mean 2 cubed? So 2 cubed is equal to 8? And I would say yes. I would say yes, that definitely this is true. And so you could say, the way you would translate this is you would say log, the base is 2, the answer is 8, and the power is 3. So same expression, there's two different ways to write log. Now I'm pretty sure that the book is probably going to ask you to write it in the way down here, but it's good to know that you can do it in different ways. It's always good to be able to do things in more than one way. Okay, so let's go ahead and go on. Go ahead and try these. Sorry, this one's actually the same one, so don't worry about that one. Let's go ahead and try the one on the right. Okay, so how do we do this? Well, here, the log form. So here we have log, the base is 3, the input's 81, and the output's x plus 2. And so this is how you write equations in logarithmic form. So now let's try to go the other way. I'm going to give you equations in logarithmic form, and I want you to write it in exponential form. So we'll start with this one, these two. So this first one, it's in logarithmic form. What I want is exponential form. And so here, remember that the 2 is the base, the 5 is the power, and so let me write that down. This is the base. This number out here is the power, and this is the answer. And so that means that 2 to the 5th is 32. And notice this makes a little bit more sense. We have done this a couple times now in a couple of videos. We do know that 2 to the 5th is 32, so that does make sense. Now let's try this other one, exponential form. Again, the 3 is the base, this 3 is the base, so I'll write it down, 3. This negative 3 is the power, and the answer is 1/27th. So 3 to the negative 3 is 1/27. And yeah, that's definitely true. You can work that out if you don't believe me. You can put it in a calculator. Okay, last one. So here's where you have some more complicated equations, and you'll see why this is important. And hopefully this will kind of lead us to a different way of solving. So the exponential form for this one. Now we're not asked to solve this, so I'm just going to write in exponential form. What this means is here the base is 5, so that's your base. The power is all of x plus 2. This is the power, x plus 2. And the answer is 125. Now, in the last video, we learned how to solve these. You don't have to do this, but if you're curious, so I'm going to put this in red just in case you're curious. You can think of this as 5 to the x plus 2. 125 is 5 cubed. And now you could solve. And so you see, this is how we're going to use this. Sometimes we're given equations in logarithmic form that maybe we don't know the answer to right away. But if we change our viewpoint and write it as a exponential form, it might be easier to solve. All right, last one. Here, the 3 is the base, and the x is the power, and the 81 is the answer. So what this means is that when I want to write this in exponential form, that we will do this by saying 3 to the x is equal to 81. So I hope this makes sense, because this is something that you'll be doing a lot for the last 2 weeks of class and on your final. So hopefully this will help you out. All right? Talk to you soon.